All right, ladies and gentlemen, we're going to kind of look at some of this here. Repeat linear. We've done repeat linear. Distinct linear, okay. Quadratic. Okay, so we're going to look at our first quadratic factor. Okay, so you guys okay? How you guys doing? I think I started to write this down. Does this look familiar? Did we do that one?
Yeah.
Did we do this x and then this x squared plus 3?
Yeah.
Oh, we did. Thank you. All righty. Okay. Okay. Is there a reason that this is not seeing what it needs to see? Okay. See? Okay. We did this one. Good. So let's warm up. Let's kind of warm up with this example. X squared minus 2x minus 1, x minus 1 squared, and then x squared plus 1. How would you guys categorize this situation? What would you guys say? What does this look like to you? Yeah, I'm going to say this. You have, what is this? Repeat linear. Is that true? So I'm going to say this is a repeat linear, and then this one over here is a quadratic, right? And that's what is always getting to me. All right, hopefully we can change. This, what would you guys call this? A quadratic. So, we have x squared minus 2x minus 1 over x minus 1 squared, x squared plus 1. So what you guys have, you got to deal with the repeat linear. So how do you deal with repeat linear? That portion here. Do you guys know? What do you do? What power, what power do you guys start with that linear term? You start with the first power, and then the next one's going to be the second power. Is that right? Now, what do you guys put as a numerator there? A and what? B. Okay. Plus, what's this? This is the quadratic factor now. And that quadratic is not repeat, is it? Do you guys agree that's not repeat? Okay, it's not repeat. So what do you guys do then? The prior what? Power for that quadratic of 2 being 1, you want to use cx plus what? D. Remember that? For a quadratic, the numerator is a linear term. So now, I hate to break the news, but now we have how many? How many constants to find? 4. Okay, we got 4 constants to find. Now, what do you guys do here? Do you guys remember? How do you do this? What's the LCM? Okay. This denominator is going to be on the bottom here when you add. That's your new denominator when you add. So what do I do with that first term? You guys remember this? You see this here with this A? This is what I do here, personally. If my denominator is x minus 1, the LCM is what you guys see here, x squared, x plus 1. What terms are missing? Right? You already have the x minus 1. So you want to know what you have to do? You got to multiply the top by another x minus 1. And I think this is x squared. Yes, it is. And then this is x squared plus 1. Because remember, it has to be the LCM. And you go to the b term. What is missing from the LCM for this b term? You have the factor of what? X minus 2 squared. What is missing? Do you guys know? From the LCM here. Well, x squared what? This is what I'm saying. You have this term from the LCM, don't you? So what's missing is going to be what? X squared plus 1. Yep. So you can kind of find what this is just by looking at it. Now you go now to the next term, and you say, well, what's the next term? Well, that's a cx plus d. This is going to be multiplied, and I guess I'm out of space, which is what I hate happening. And then what's the deal here? You say, this already is a what? X squared plus 1. You see, isn't that x squared plus 1 there? So what's missing then? The x minus 1 what? Squared term. Is that true? X minus 1 squared. Okay, you guys see what I'm saying? How that can easily be done. And then what I'm going to say now is these fractions are equal. They have the same LCM. What does that mean about your numerators? That means the numerators have to be equal. Is that right? So what do we have as a numerator now? That's going to be x squared minus 2x minus 1. What does that equal? Ax minus 1, x squared plus 1, b x squared plus 1 plus 6 plus d x minus 1 squared. Okay, because it's going to use the fact that if you have equal fractions, what has to be? They equal fractions with the same denominator. What does that mean? It means your numerators are the same. Okay, so now we're in business, right? But you guys are going to notice something here. It's not as easy as you think, right? What do I mean by that? Okay, what do I really mean by that? We're going to have to let now. How do we start to handle this situation? If I want to zero out this term, what does x have to be, right? X is what number? 1. Is that true? So if I plug in a 1 on the left, here, what do I get? 1 squared times 2 minus 1 minus 1. And then this is going to be what? 1. Is that right? In fact, everywhere it's going to be 1, everywhere that there's an x term. And so notice this. The reason you want x is 1, that's going to be 0. But isn't this going to be 0 too? If you plug in 1? Okay. Then what do we get on the right side? You get what? B 1 squared plus 1. And now you get what? 1 minus 2 minus 1 is going to be what? 2b. And that means now negative 2 equals what? 2b. And then what does that mean? What is b? Negative 1. Okay, you guys okay with that? So far, so good? Because this might be part of the hardest part for some. And partial fraction decomposition. And then I'm going to say to you guys, you might say, but Mr. Judge, I don't see any other terms that can start to zero things out, right? Because there really isn't any other, is there? You don't have like an x minus 2 factor where you say x is 2 and it zeroes it out. You don't have like an x plus 1, you say x is negative 1, zero it out. So you go, oh my God, what's the problem now? Well, remember, you can actually let x be any number. So if I said, I always go to 0, why do you guys think I go to 0? Why is 0 a good option? Huh? What if you go to 0? Yeah, it makes your arithmetic easy. 0 is always good with arithmetic. I always use 0. Good job. So 0 squared minus 2 times, you know what I can see right away? The left side's just negative 1. Is that true? You guys know what I mean? The right side, I'll have a, what's 0 minus 1? Negative 1. What's 0 squared? Isn't that going to be positive 1? And then you get plus what here? What's 0 squared plus 1? 1. That's for the b term. What about the c term? Isn't that plus? If x is 0, that's d times 1. And so what I'm saying is you get negative 1 is negative a plus b plus d. What is b again? Negative 1. Do you guys know what this means, by the way? It means negative 1, negative a minus 1 plus d. What does that mean now? It means negative a plus d equals what? 0, or it means a equals d. Okay, that's good information because if I ever find the value for a or d, what do I know? It's the same. So don't look at this and say, oh, this what? This didn't get me anywhere. No, it's more information. Okay? Now, maybe at this point now, again, let's get rid of this. You know what I can do? I can kind of do another thing where what? I can let x be another value. And I can try to create an equation. And then let x be another value and try to create another equation. But you want to know, I can kind of see something here. Maybe it's easier to do that. But remember what I started to do yesterday? What did I start to do yesterday, if you guys remember? Remember I showed you guys, I said something like this. I said, you know what we used to have to do back in the day? They didn't do it this way. We had to do some algebra. So, I mean, yeah, maybe we want to do something here. A is D. What can I do? I think I could do a few things here. Can I say something here about this? Let's go back. You see this is 0x cubed? I think I can say this. Tell me if you guys agree with this statement. Is A plus C equal to 0? Just to make an observation. How do I know A plus C might be 0? If you start to do algebra here, what I'm saying is if you multiply by FOIL, doesn't that first term give you an x cubed? And then that gives you the ax cubed. Is that true? You with me on that? And then over here, if I start to do FOIL again, what do I get?
CX squared.
Well, if I do FOIL, remember, this is going to square. So I get an x squared term, right? And then the x squared term times the x gives me another, what, x cubed for that first term. And then so that's cx cubed. And you go, oh, does that mean both a plus c then is 0? It does, because there's a what term here? Yeah, there's on the left side, you got that cube. So you might say, bless you. You might say, oh, I don't know if that helps me much. It kind of does. Because what that means now is a also is negative what? C. Okay? Because a plus c is 0 means a is negative c. All right, well, there's a few things I can do now. What would you guys want to try? Just kind of seeing what you think. What would you guys want to try here? I think there's a few things I can do. You know what? Let's do x is 2 maybe, right? Let's see if we could get there by saying, let's let our x value be 2. How's that? Why might 2 be kind of nice? Where's our equation? Plug in a 2. What do you get on the left? Two squared minus what? 2 times 2 times negative 1. What does that equal? A. What is 2 minus 1? Isn't that 1 for the a term, right? And then you have 2 squared plus 1. Isn't that 5? So double check. So I'm going to say times 5, okay? And then that's plus 5b, right? Look at the b term. 2 squared plus 1, isn't that 5b? And then what do you have here? You have what? 2c plus d. Because you're going to plug in what? The x and the 2 over here. And then what's this 2 minus 1? Isn't that 1? So you get 1 squared, and that's 1. Is that right? So you get 4 minus 1 is now 5a plus 5b plus 2c plus d. Now let's see what this says. This is negative 1. And I'm going to use, since I have a b value, what am I going to use for b? B was negative 1. Is that true? So I'm going to say negative 1 equals 5a minus 5 plus 2c plus d. Add your 5 to both sides, and you get what? 4. 5a plus 2c plus d. So what do you guys think we can do with this now? I think we have something here. We got something. What do we have? I think I'm going to put a happy face. Why are we happy? Yes, why are we happy?
Can you say that D equals 5A plus 2C over 4?
Well, remember, what is D again? D is what? A. And then what is C? Negative A, is that right? If A is negative C, then C is negative A. Why do you guys think that's a good thing? Why is that nice? What is this?
Well, you just add them?
Yeah, everything's in terms of A. So if it's 5A, now minus what? 2A plus A. Why is that nice? That's why I put a happy face. Is that 4A? I think it is. What does that mean about my A? We got A as 1. And that I'm really, really happy now. Why am I extremely happy?
Because C equals negative 1 and B equals
Because if A is 1, that means what here? D is 1. Is that true? If A is 1, that means C is what? Negative 1. So, moral of the story, ladies and gentlemen, I did a combination of those two approaches, and it's going to work out. And now I get to plug in the values for A, B, and C, and D. Now, what is A? Forgot. A is 1. Is that true? So go back to your original question here. A is what? 1. What was B? Negative 1. Okay. And then what is C? C and D. What is C? C is negative 1, and D is positive 1. One over x minus 1 minus 1 over x minus 1 squared, right? Plus, I'm going to say this is 1 minus x over x squared plus 1. Is that true? Because c is negative 1 multiplied to x, and then d is 1. So your original fraction, this is what you guys get. And then what's the idea? You're going to integrate this. What do you guys think you want to do here? What do you guys think? What did I do over here on the right side? Do you guys remember? What did I do? I used the distributive property, meaning you're dividing a difference by two numbers. You can separate that difference. And then why is that a good thing? Yeah, we actually have what? 4 integrals, right? Anybody know? Where do you use up? Here, what do you guys use? U sub. What is U? X minus 1. And then, what do you guys use over here? U sub. Okay, what is U? X squared plus 1. Is that true? And then let's see if you guys are awake. This is one of my all-time favorite integrals. Isn't that inverse tangent? Yes, good job. Look at that, you guys. Okay. So, ladies and gentlemen, there you go. Here's your final answer. And I don't know. I don't like using that circle, but... Okay, you guys okay with that? I'm just saying this is your integration here. So, this is how you handle that particular what? Situation. All right. I don't think we did this, but we'll try this one here. Okay, you guys ready for a granddaddy? Granddaddy, sorry. Okay. So how would you handle or classify this question here for you guys, right? How would you classify this? Let's look at it. This is going to be, what kind of factor is that? Linear. Okay. And what do you think about this one? Isn't that quadratic? Repeat. This is linear. And then what's this? Repeat quadratic. So does that make sense? You guys see what I'm saying? Oh my gosh, what do you guys say? Oh, we forgot the dx. Okay, so I'm going to do this here. How do we do the partial fraction decomposition here? I'm going to say 3x plus 4 plus 4x cubed, 16x squared, 20x plus 9 over that denominator. This equals what? What does it equal? You deal with a linear term. Is that true? And then that's an A. You guys with me on that one? So I think this is your first repeat quadratic. Is that true? So I'm going to emphasize, this is your first repeat quadratic. So then how do we repeat this quadratic? X squared plus 3 to the first power, and then x squared plus 3 to the second power. Yes?
So the top portion for the first one, the bx minus c, and the other
Be careful, bx plus c. Okay, you okay? I mean, you could do minus c, but it's not. It's bx plus c, but just be careful, right? You want to be consistent. But what is the next one going to be? Dx plus e. Oh my God. Horrible. Oh my God, what do you guys think? Okay, now you can say, okay, what is this going to be equal to, right? Well, you're supposed to add these terms, and then it's going to be the LCM, and that's saying that equals to this. So let's try to make sure you guys really understand this partial fraction decomposition here, okay? Remember how you start, because you're really adding here, adding rationals. And with this first term here, you got a. Let's see if you guys remember. Don't you already have an x plus 2 term there? So what does that mean? This would be x squared plus 3 what? Squared. You okay with that one? Okay. And then you go into the next numerator, bx plus c. Now that's a sum, so put it in parentheses, right? And what do you guys see now? What is this? That's an x squared plus 3. So you're going to write this as what? X plus 2 times an x squared plus what? Plus 3. Plus dx plus 3, dx plus e. So you're going to go here, you're going to say, okay, it already has the factor of an x squared plus 3 squared. So what do you guys multiply here with? Dx plus 2, you okay with that? Okay. I mean, that's how I very simply do it myself. But you're adding, you know, you're really adding rationals. You're going through that process. But, you know, equal fractions, they have the same denominator now. What that means is your numerators are the same. Is that right? So that big numerator, I'm going to copy it. You know, I'm going to copy that. That numerator equals this numerator. A, x squared plus 3 squared, bx plus c, x plus 2, dx plus e, x plus 2, and I think that is it, right? Double check. Is that it? Yeah. I forgot what? What did I forget? Oh, there's an x squared plus 3 with the bx plus c. Is that true? And I want to remark something about this so you guys know. You might say, Mr. Judge, what's the deal here? If I let x be negative 2, I can zero out a couple of terms, I guess, right? And then I might be able to get an a value. Is that right? So I'm going to get what I can handle. If x is negative 2, what do you guys think we're going to have to do? You know what you're going to get if x is negative 2? You're going to get a. A is going to be positive 1. Right, because really, I'm sorry, over here, right? Isn't that 4? You say negative 2 squared is 4. 4 plus 3 is 7. 7 squared, is that 49a? But you got to plug negative 2 over here, 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 and here. So you guys can double check. But I get when x is negative 2, a here is going to be what? Positive 1. And you can double check that work. But what I want to also say to you guys is that's the only easy one you can get. Is that right? You say, what do you mean easy? Well, there's only one linear term. And quadratics, the problem with the quadratic is you can't zero this out, right? You got x squared plus 3. You're not going to zero that out at all. So then you might say, well, what's left for me to do? Well, what could you do if that's the case? Well, you might. And if you start taking cases, x is 0, right? On the left, you get 9 equal to x is 0. We get what? 9a. And you go, oh, x is 0 here. So this is going to be a little bit more work here. Then that means a c times 2, and it looks like it's be times 3. Is that true? So is that 6c? Okay. X is 0. Wherever there's an x, there's a 0 here. Okay. X is 0. So what is that going to be now? Plus what? E times what? 2. 9 equals what? 9a 6c plus 2e. And what do you know about the value for a here? You guys know a is what? 1. Okay. So 9 equals 9 plus 6c plus 2e. And ladies and gentlemen, this means what? You guys know what that means? 0 is going to be what? Divide both sides by 2, and what do you get? 0 is what? 3c plus e. Or e is going to equal negative what? 3c. So double check my arithmetic, ladies and gentlemen. I know the coffee hasn't kicked in. I'm going to have a meeting today, you know. But okay, what else you guys think you can do here? That was an easy one. You know what I might do? What do you guys think? Should we do some algebra over here? I don't know. Can we do some algebra? All right, ax squared plus 3. So I'm going to do this here. So you guys, we're going to copy that top. I'm going to try to create some nice equations here. All right? So we got ax squared plus 3. You guys know what that's going to be? I'm going to do it this way here. Isn't it x squared plus 3, x squared plus 3? Let's start to write that down. And then we just have to repeat this. Okay, so I'm going to start to do a little bit of algebra. Copy this one here. Paste this one. And this is where my algebra is going to equal. I think this is going to be A. And you get what? X to the fourth plus 6x squared plus 9. Okay. Plus the bx plus c. I'll leave that there. And now this is going to be x cubed first, outer 3x. 2x squared plus 3x plus 6. Okay. And then you say, what's this going to be? Well, that'll be dx squared first term, outer term, plus 2dx. Inner term, ex, last term, 2e. Okay. So I'm going to keep copying this. I'm going to say this equals. Okay, so that numerator there, we're going to say, what is this going to be now? Ax to the fourth plus 6x squared plus the 9a, okay? And then I'm going to do some distributive property here. Bx to the fourth, do the b term. 2bx cubed, do the b term. 3bx squared, 6bx. Now the c term there, so that's going to be cx cubed plus 2c x squared plus 3cx plus 6c, and then you already had what you had here. Okay, it looks like we're okay there, right? Alrighty. What's that?
The 6x squared means a.
Sorry. All right, what am I looking at here?
Where it says ax to the power of 4 plus 6x squared, forget the 8.
I've got the 8. Thank you. Ooh. We're really gonna mess that one up. Good. Okay, so here's what we're gonna do here with this. What do you guys think we're gonna do? We're gonna combine like terms. X to the fourth, x to the fourth. Is there another x to the fourth? No, is that true? So you know what that's going to mean? This is going to equal what? A plus b, x to the fourth. Is that true? And then what power comes next? Do you guys know? We're going to do this. 2bx cubed, cx cubed. Two b plus cx cubed. Okay, what power comes next? 6ax squared, 3bx squared, 2cx squared. So what do you guys think you're going to say? This is going to be what? Isn't that 6a, 3b? 2c, x squared. We forgot we forgot what? Guess what we forgot? Dx squared. All right, let's do the linear term now. Six bx, 3cx, 2dx, ex. So we're going to say 6b plus 3c plus 2d plus e, and now that's x. Followed by 9a 6c 2e, 9a plus 6c plus 2e. 9a plus what? 6c plus 2e. All right, so there we go. Double check. Did we get every term? I hope. Okay, so now what does this mean? You say, what does this really mean now? Well, don't forget, well, what this means is a plus b has to equal what number? 3. So you say, how is that? Do you guys know how we're doing that? This constant has to be that constant. Because the left side equals right side. That's the x to the 4th. 2b plus c, what does that have to be? That has to equal 4. Is that true? All right. And then what do you have? 6a plus 3b plus 2c plus d. That equals the x squared term. So that equals what number? 16. You guys see what I'm saying? This portion has to be 4. Bless you. This portion has to be 16. And then, what are we saying here? This portion has to equal 20. Is that right? So 6b plus 3c plus 2d plus e, that has to be 20. And then I guess I'll use gold. That's 9. Okay, and you go, oh my God, what does all this mean? Well, what was A to begin with? What do you guys know? Go back over here. A is 1, and E is minus 3C. So I'm going to put here, A is 1, and so notice if A is 1, what does that mean? A is 1, what is B? Isn't B 2? Is that right? And if B is 2, go back over here. What does that mean? 4 plus C is 4. What does that mean about C? C is 0. Is that true? Okay, but what else? I thought I seen a C somewhere here. What is this? What is E? E was minus 3C, wasn't it? So since E is minus 3C, what does that mean about my E if I substitute? Isn't E also 0? So we got A, we got B, we got C, we got E. We just don't know what D is. How am I going to get a D, ladies and gentlemen? I can probably use this, is that right, to get D? So you say, what would I do here to get D? Well, what is A? 1. What is B? 2. What was C? 0. What was D? Oh, we're trying to get D. 6 plus 6 plus D is 16. Is that true? $12 plus D is 16. What is D, ladies and gentlemen? 4. Okay, so that's what you're going to do to go plug in your constants over here. Repeat quadratic. So, okay, let's plug in the values here. A is 1. What is B? B was 2, is that right? 2. What is C? 0. What was D? 4. What is E? 0. So we're really going to integrate this, is that right? So how many integrals do I get now? Okay, you guys good with this one? Now, how do you integrate each one of these? What am I going to say? This one's going to be what? Yeah, it's u sub, but it's going to be ln absolute value x minus 2. This is my u. This is also going to be what? U sub. X squared plus 3. That's nice. What is u here? X squared plus 3. This is also u sub. So the least they can do, if they made us solve that horrible system by substitution, and the technique I shared with you guys, the least they can do is give us a nice, easy kind of integration. And they did. And let me share with you guys, here's your final answer. Natural log absolute value of x plus 2. Natural log x squared plus 3 minus 2 over x squared plus 3 plus a constant. So, ladies and gentlemen, anyway, that's the various techniques that we went over. Now, remember, don't I have videos on my website? Is anybody watching them by any chance, working on that? I hope. So you might have some extra examples there. But as you guys can see, for partial fraction decomposition, the reason on a test I have 2 parts, in class and take home, because I don't think it's good to ask you only 3 questions on a test. So something like this, like a repeat quadratic, you might have to do at home. You guys see my point? So it's kind of weird where if the course is a calculus course is taught on an hourly basis, that you kind of want to do this. I should say what? Well, it's thought of really as a quiz and then a take-home portion. That's the best I could describe it. So I would tell you, I'm not going to give you that. I mean, I'm going to give you these kind of things, but probably on a take-home portion. Because I just don't think you can't give like 10 of these questions on a test and have people complete it in 70 minutes. But I still want you guys to go over that and look at it. So I think I put your homework already. It's in Canvas. Is that right? Try to do these homework questions. There's not going to be any class on Monday. I'll be in Sacramento arguing on behalf of students. You guys know? Anyway. What's that? No, it's actually for community college students in the state. Maybe I'll send you guys a video to watch during this on Monday or something, and you can understand what I'm talking about. All right, because I had to talk about this with all the other classes, but yeah, it's complicated. It's horrible. But anyway, okay, you guys, I'll upload this video later.